In the previous class, we have just seen what is the classical relation with fuzzy set. Today, we will be discussing about the problems based on this. Before going to the problem, we will just analyze what is the classical relation. The classical relation with the two fuzzy logic. So here in this classical relation, x cross y is given by x comma y, where x belongs to capital X, y belongs to capital Y. Y belongs to capital Y. Here the Cartesian product form the ordered pair of every x belongs to x with every y belongs to y. So I say that there is a characteristic function x cross y of x comma y which is equal to 1 if x comma y belongs to the Cartesian product of x cross y, 0 of x comma y if it does not belong to x cross y. So this lambda, it is nothing but the characteristic function which tells you what is the relation, what is the classical relation between x cross y or the Cartesian product of x and y with the variables of xy. So if xy belongs to the Cartesian product x cross y, then it is 1. If it does not belong to x cross y or the Cartesian product, then it is 0. Okay. So now we will take one example, that is x cross y, which is equal to p comma 2, p comma 4, p comma 6, q comma 2, then we have q comma 4 and q comma 6, r comma 2, r comma 4, r comma 6. Now this is x cross y, where x is equal to p, q, r and y is equal to 2, 4, 6. Now these are the two sets. Okay, these are the two sets which are belonging to x and y. When I perform the Cartesian product, it gives me what? The product of all these, that is the Cartesian value, that is p cross 2. Every element of p is multiplied with p cross 2, p cross 4, p cross 6 and q cross 2, q cross 4, q cross 6, r cross 2, r cross 4, r cross 6. That is, every element of x is being multiplied or having the Cartesian product with y. Now, if R is a subset, then p comma 2, q comma 4, r comma 4 and r comma 6. If this is a subset of x cross y, that is, then they contain some values like p comma 4. Then after I represent it in the matrix format, that is, you have R, P, Q, R, then we have 2, 4, 6, 1, 0, 0, 0, 1, 1 and then 0, 0, 1. Now what does this matrix indicate is, now I have with R, P comma 2. So P comma 2 will be what? R is 2 and 1. So it is nothing but it is going to have a value 1 because it is contained in the Cartesian product of x cross y and R is a subset of x cross y. Now Q is also 4. Q comma 4 is there, R comma 4, R comma 6. These are the subsets of the Cartesian. If I want to represent whole of the sets, then I should have what? P, Q, R, 2, 4, 6. Everywhere I will have 1. But now R is a subset of x comma y. So x cross y, then I can have this as a representational matrix. So I say that the relationship here in this classical, usually we denote it by mu as a membership function. Here it is a characteristic function of x cross y of xy is equal to 1 if it belongs to subset. Otherwise it is, if it is not, does not belong to the subset, that is R. So this is what we have with the classical relationship. Then you have the cardinality of classical relation. How do you, the similar way you have a cardinality of fuzzy relation or the fuzzy set. On the similar way you have the cardinality represented by this characteristic function. There we have lambda of x into lambda of y. So this we had represented in the fuzzy set as 2 mu x into mu y. That is, the mu was the membership function over there. Okay. There are some operations on classical relations. The operations what we are going to perform on classical relations are union, intersection, complement, containment, identity. In the previous class, I just showed you what are these. Union is nothing but the maximum. Intersection is nothing but the minimum value between the two characteristic function now. Instead of membership function, we are going to depict it as a characteristic function. Complement is nothing but 1 minus the characteristic function of whatever the set you have been given. Containment is nothing but the subset or the values which are lesser than the main whole set what we have. Identity is nothing but it may be either a null set or a set which is equal to 1. So we don't have the properties of crisp relations and composition of classical relations, so we will just skip them. Directly we are going for the fuzzy relations. So in fuzzy relations, I need to represent this fuzzy relation with some characteristic value, that is, you have the fuzzy relation being represented as fuzzy relation. So in this fuzzy relation, similarly how we have the fuzzy set, that is, what is the probability of appearing this particular value in that particular set. Okay. On the similar lines, we just take one example. So the fuzzy set, let x is equal to capital X is equal to x1, x2, x3 and x4. Okay, and capital Y is equal to y1, y2, y3 and y4. Okay, let R be the relation from x to y given by R is a fuzzy relation with classical relation. So R can be represented as 0.2 that is by x1 comma y3. So the containment of x1 and y3 is 0.2, the probability of appearance. Then we have 0.4 divided by x1 y2, that is the occurrence, the probability. 0.1 divided by x2 y2 plus 0.6 divided by x2 y3 plus 1 divided by x3 y3 plus 0.5 divided by x3 y1. This is nothing but the probability of appearance of x1 y, whatever the variables you have with x and y. So when I do the fuzzy relation, now the corresponding relation, here we have depicted the Cartesian product in terms of matrix. If I want to depict this particular thing in terms of matrix, then I should have x1, x2, x3. See, whatever the values I have here, I am going to take them, y1, y2 and y3. So x1, y3 will be 0.2, x1, y2 will be 0.4, x2, y2 will be 0.1, then x2, y3 will be 0.6, then x3, y3 will be 0, it is 1. Then we have x3 and y1 we have 0.5. The rest all will be taking the values of 0. This is how I am going to represent the matrix format for the fuzzy relation with the classical relation. Okay, there are some operations on fuzzy relation similar to the we have with the classical or the Cartesian product. These are with the union, intersection. Again, union goes with maximum of mu r of xy, mu s of xy. Intersection goes with minimum. Complement is 1 minus membership function of R with xy. Containment is nothing but the subset. We also have the inverse and the projection. Just we will look them when we go with the problems. So the properties of the fuzzy relations is R union R bar will be equal to E. That is nothing but the whole set. R intersection R bar will be equal to the null set. This is a general idea behind the union and intersection values. Okay. So the fuzzy composition, this is very important. Many of the problems which are based on this, that is the fuzzy composition. So in the fuzzy composition there are two types. I'll just write them. We require them to solve some of the problems here. The problems are very important from this chapter. We'll just solve some of the exercise problems also along with the solved problems in your textbook. So here we have fuzzy composition, fuzzy technique. So the fuzzy composition techniques are fuzzy max-min composition, fuzzy max product composition. Fuzzy max-min composition and fuzzy max product composition. Sorry. We will just note down the formula because this is required for finding out the mu t of xz, which is equal to mu of r dot s of xz, which is equal to max of y belongs to y, minimum of mu r of x comma y, mu s of y comma z. This will be equal to then we have the max product composition. We have mu t of xz, which is equal to mu of r dot s of xz, which is equal to max of mu r of x comma y dot mu s of y comma z. So this will be equal to, for every y belongs to capital Y, mu r of x comma y dot mu s of y comma z. So these two formulas are important from the problem point of view. We have the max-min composition given by xz, that is the transitivity property holds. If there is a relation from x to y and y to z, we have a relation from x to z. So xz will be equal to max of min of mu r of xy, and you have mu s of yz. Just look here, you have y as a common. So I am going to compute a relationship or the membership function with respect to xz. On the similar lines, we have dot product, that is the max product combination with fuzzy logic as r dot s xz is equal to max of mu r of xy. Okay, here it is minimum, here it is just a product rule, dot mu s of yz. So I just multiply them and keep the values. When we go with the problems, it will be very clear. We will take for the first problem. The elements in the two sets A and B are given by A equal to 2, 4, B equal to ABC. Find the various Cartesian product of these two sets. This is very simple. Some two sets will be given to you. Suppose for example, I have 2, 4 and B is going to have x, y. I need to find out Cartesian product of all possible values. That is A cross B cross A cross A and B cross B. So this will be A square and this will be B square. These are the possible Cartesian products what I may get from these two sets A and B. Simple. We'll go for the next problem. Consider the following two fuzzy sets. We have, I'll just take this problem. So we have just looked into how to represent the classical relation, how to represent it in the format, in the matrix format. What is fuzzy relation with respect to classical relation? How to represent the fuzzy relation with respect to classical relation in the matrix format. And we have seen two important composition techniques of fuzzy, that is max-min composition and max product composition. I request you to note the problem. A is equal to 0.3 divided by x1 plus 0.7 divided by x2 plus 1 divided by x3, and B is given. This is a fuzzy relation, fuzzy set 0.4 divided by y1 plus, this is x1 y1 plus 0.9 divided by y2. Now these two fuzzy sets given. Perform the Cartesian product over these two given fuzzy sets. Now I need to perform the Cartesian product with these two fuzzy sets. So we have mu of x1 y1, which will be equal to, when I say x1 y1, we have, what is the Cartesian product of A cross B? It is nothing but you have minimum of, mu A of x comma mu B of y. Okay, so now y1 x1, so x1 y1, what is the minimum value here? Minimum of mu x, that is 0.3 comma 0.4, I'll be getting it as 0.3. On the similar lines, the membership function of x1 y2, so I can have minimum of x1 y2. I need to perform the Cartesian product. Now if I have a simple number, I just did it here, a equal to xy and b is equal to 2 4. What I do, x into 2, x into 4. On the similar lines, I need to perform 0.3 by x1 into with respect to 0.4 by y1, 0.3 with respect to 0.9 by y2. Now I have taken x1 y2. Okay, next I'll take x2 y1, x2 y2. Then I'll take x3 y1, x3 y2. Now all possible combinations of Cartesian product with two fuzzy sets is done. So I need to perform, what is the logic? Minimum of 0.3, 0.4 is 0.3. Now I should check with x1 y2. What is that? 0.3 and 0.9. Minimum is 0.3 again. Next I should go for membership function of x2 y1, which will be equal to minimum of mu A of, I am not writing this again and again because we know what is that value, mu of, I am just writing here y1. So this will be equal to mu of x2. What is x2? 0.7, minimum of, okay, 0.7 with respect to 0.4. What is the minimum value? It is 0.4. So I get the value as 0.4. On the similar lines, now I will perform the Cartesian product with these and these. So that is how I am going to get the different combinations of Cartesian products for the two given fuzzy sets. Okay. On the similar lines, with the page number 293, you have the same type of problem. For the second problem, for the fuzzy sets given 0.5 by x1 plus 0.2 by x2 plus 0.9 by x3. B is given as 1 by y1 plus 0.5 by y2 plus 1 by y3. So two fuzzy sets will be given to you and you need to perform the Cartesian product of these two fuzzy sets. Next, we are going to solve some problems which are based on two fuzzy composition techniques, that is fuzzy max-min composition and fuzzy max product composition. Now down the fuzzy relations are given as R is equal to, you have x1, x2 and y1, y2, y3 as 0.1, 0.2, 0.3, 0.4, 0.5, 0.6. Then S is given by y1, y2, y3. Then you have z1, z2, z3 as z1 and z2 are there 0.8, 0.1, 0.6, 0.9, 0.4. It is 1. These are the two fuzzy sets given to you. Fuzzy relations. Perform composition over the two given fuzzy relations. So the two fuzzy given relations are max min composition. Okay. So first one is max min composition. Second one you have max product composition. Max product composition. So for the max min composition, note down max min composition. We have mu t, that is r into s. R dot s will be represented by t of x1 z1, which will be equal to max of minimum of mu r of x1 comma y1, then mu s of y1 into z1, then minimum of x1 z1. So x1 z1 is given here. So you have and minimum of mu r of, that is membership of x1 y2 and y2 mu r of y2 z1. Okay. So now see x1 z1, if I want, I should take x1 y1 z1. Then x1 is also related to y2, so I can take x1 y2, then y2 z1 will also give me what? The same thing, that is two relations. So I can have here max of min of 0.1, that is x1 y1 will be equal to 0.1 comma y1 z1 is 0.8 comma minimum of pure of x1 y2 will be 0.2, y2 z1 will be y2 z1 will be 0.6. So among this, which is minimum? Max of minimum is 0.1, here minimum is 0.2, max will be equal to 0.2 will be my answer. Minimum of mu r x1 y2 z1. So both I need to consider. Okay, since we have 3 there, I can go ahead with minimum of mu r of x1 y3, then mu r of y3 z1. So this will be what? Minimum of x1 y3 will be 0.3 and y3 z1 will be 0.4. Minimum of this will be 0.3 and max will be 0.3 here. So you can add here 0.3. So answer will be 0.3 because I have 3. Here it is 2 cross 3 and here it is 3 cross 2. So I should get what? 2 cross 2. Correct? I should get 2 cross 2. See, 2 cross 3, it is 2 rows and 3 columns. Here it is 3 rows and 2 columns. So I should get what? 2 cross 2 as my product. Okay, so that is what we are going to get it. On the similar lines, now if I want to go for mu t of x1 z2 will be max of minimum of mu r of x1 y1, okay, comma mu r of y1 z2 y1 z2, correct. Then I can have minimum of mu r of x1 y3, then I can have mu r of x1 y3 and y3 z2 y3 z2. So I can have here minimum of mu r of x1 y1 will be yes, x1 y1 will be 0.1 minimum of x1 y1 and y1 z2 will be 0.1, then y1 z2 will be yes, and x1 y3 will be x1, this is minimum, x1 y3 will be 0.3 and y3 z2 will be y3 z2 will be 1, comma, then I may have x1 y3 y2 x1 y2 yes, x1 y2 yes, x1 mu r of x1 y2 x1 y2 and y2 it is z2, x1 y2 to z2 yes. So this is there, x1 y2 will be 0.2 minimum of this 0.2, y2 z2 will be 0.9. So among this minimum will be you have 0.1, 0.31, it is 0.3, 0.2, 0.9, it is 0.2, max among this will be 0.3. So this is your answer for x2 z2. On the similar lines I should go for x2 z2 is done, then I can have yes. So these are the values what I can have with membership functions. x1 z1, x1 z2, x1 z3, x2 z1. So all possible combinations. See, x1 z1 I should calculate, then x1 z2, x2 I can have x2 z1. I have not calculated this now. So I have calculated x2 z2. So this I have calculated. So you are supposed to calculate x1 z2 also and x2 z1. So now if I want x1 z2, so I should take max of minimum of membership function of x1 z2. So x1 z1, no, x1 y1 z1, okay, yeah, y1 z2, then minimum of mu r of then x1 z2 is there, right? So I can take x1 y1 z2, then x1 y2 z2, okay, then I can have mu r of x1 y3 and y3 z2, okay. So x1 y3 z2. So everywhere I should get these. Everywhere I should get x1 z2. So now this will be max of minimum of x1 y1 z2. x1 y1 is 0.1 and y1 z2 will be 0.1. So this will give me 0.1 only. x1 y2 will be 0.2. x1 y2 will be 0.2. y2 z2 will be 0.9. So minimum among this is 0.2. Then I have x1 y3, it is 0.3, and x1 y3 z2. So y3 z2 is 1. Sorry, it is 1. So minimum among this is 0.3. Max among these three will be 0.3 as my value. So this I have done. On the similar lines, you need to go for x2 z1. So x2 z1 will have the combination of x2 y1 z1, okay, and x2 y2 z1, and x2 y3 z1. So these are the three possible combinations what you are supposed to go and calculate and get the value. This is how you are going to get for the max, min this is max min composition. Now max product composition is nothing but you are going to have the product. We'll just take a look with that. I hope this is clear. Okay. So it is nothing but the possible combinations of to get the x1 z1. So if I want x1 z1, I should take intermediate as y. Okay, because that is your product what you are going to have. Y is the common in both the matrix. So I have to find out x1 to z1. So x2 to z2 will be minimum of x1 y1 y1 z2. Wherever you get, it should always result in terms of x2 and z2. Okay. So next is we are going to have the similar kind of problem with max product composition for the same. Okay. So max product composition is given by the formula. I'll just write. It is same except the min and max you are going to have the product. Except the min and max you are going to have the product. I'll just go for one solution so that you are able to go for the subsequent things. So second one is max product composition. Max product composition, suppose I have mu t of x1 z1 will be given by max of mu r of x1 y1 dot product of mu s of y1 z1 comma mu r of x1 y2 dot product of mu s of y2 z1 comma. Now I have three matrix, so I should have x1 y3 dot product of mu s of y3 z1. Just look here, we need to have the max of this. So mu r of x1 y1, what is x1 y1? It is 0.1 into y1 z1. What is y1 z1? 0.8. Product of these two, comma mu r of x1 y2. x1 y2 is 0.2. Similar it is. x1 y2 will be 0.2 and y2 z1, that is y2 z1 will be 0.6 multiply comma y2 z1 y2 z1 x1 x1 into y3 x1 y3 is 0.3 into y3 z1, so y3 z1 is 0.4. So I need to multiply these two, that is 0.1 into 0.8 is 0.08. Yes, 0.08. Next I have 0.2 into 0.6, it is 0.12. This is 0.12. Max among these. So max among this will be 0.12 will be my answer. Now suppose I want the max product composition of mu t of x1 z2. What will be the answer for this? x1 z2. I can have max of mu r of x1 y1 dot mu s of y1 z2, correct? Then mu r of x1 y2 dot mu s of y2 z1, correct? Sorry, z2 y2 z2, that is x1 z2. Then I should have mu r of y3 x1 y3 dot product of mu s of y3 z2, correct? Z2, correct. Okay, so now just multiply the things. You have max mu r of x1 y1. What is x1 y1? 0.1 into y1 z2. y1 z2 is 0.1, so it is 0.01 comma Then you have x1, y2. X1, y2 will be 0.2 and y2, z2. Y2, z2 will be 0.9. 9 to the 18, so 0.18. Correct? Then you have x1, y3. X1, y3 is 0.3 and x3, z2. X3, z2. X3, sorry, not x3, z2. It is y3, z2. Correct. X1, y3, X1, y3, X1, y3 will be 0.3, y3, z2 will be 0.1, so it will be 0.03. So max among this will be 0.18, so your answer will be 0.18. Did you get the point? How did I just go with the max product composition? Max product composition is given by max of UR, x2, y. Whichever variable you want x1, z1, take the intermediate as y and then perform the calculation. Now if I want mu t of x1, x2, z1. So what will be the values? x2, z1. x2, z1 will be given by max of mu r of x2, y1 dot product of mu s of y1, y1 it is z1 because you want x2 and z1. So I am going to take it as y1, z1. So the final combination should be x2 and z1, whatever we require, the membership function with x2, z1. Then I have mu r of, so this is dot product. Okay. So next I should have x2, y2 dot product of mu s of y2 into z1. Okay. So y2 is common. Next I should have mu r of x2, y3 and mu s dot product of mu s of y3, z1. So this I want with the calculation. So this will be giving me max of mu r of x2, y1. x2, y1 is 0.4 into y1, z1. y1, z1 is 0.8. So it will give me 0.32. Okay. And mu r of x2, y2. x2, y2 is 0.5. Dot product of y2, z1. What is y2, z1? It is 0.6. So it will give me 0.30. Okay. And the next value will be x2, y3. So x2, y3 is 0.6 into y3 z1. So y3 z1 is 0.4. So this will give me 0.24. So max among these three values will be 0.32. So this will be my answer with the max product composition of mu t x2 z1. Now you are supposed to calculate with mu t x2 z2 and you can yes, mu t x2 z2. This is another value what we need to calculate. So this will be the answers at 0.32 once we calculate with the max, because the whole composition is associated with max value of the values whatever you get inside with the membership function with the dot product. So these problems are important. Another type of problem what they may ask you is the page number 288 with some problem, that is the speed control DC motor. The membership function follows. That is, you will be given with some values, like we have taken the signal increasing, decreasing in the fuzzy set. On the similar lines they are given you, then you need to perform both the operations, that is max mean composition and max product composition. Type of problem one. So I have value given as 0.500 0.8 by 100, so 0.7 by 200 plus 0.6 by 300, and high value is given by 0.8 divided by 100 plus 0.9 divided by 200 plus 1 divided by 300. So I need to perform the Cartesian product with low cross medium, medium cross low cross high, and also with medium cross high. These are the three possible combinations what I need to perform. So low cross medium. So every element of low has to be performed with a Cartesian product of medium. So I'll just take this. So we have R as low cross medium. So this will be representing it as 0, and this, among this it is nothing but your minimum value. Cartesian product what we are going to have is minimum of mu r of low comma mu r of medium. Actually we are going to do this, calculate the minimum value. Now if I take the base is same 100, so I need to just analyze with every value of so the base is same, so I can represent this as 100, 200, 300. R is represented as 100, 200, 300. Here also 100, 200 and 300. So here the minimum value among these two will be 0.1. That is, you have 0 and 0.5, so it is 0. 100 with 200, it is 0 again. 100, 300, it is 0 again, because this is the minimum value what we have with low. Then we have low with, then every possible of low has to be compared with medium. So 200 with 100, 200 with 100, it is 0.1 minimum value. Then 200 with 200, it is 0.1, because 0.57 is greater than 0.1 what we have in the matrix here. Then 200 with 300 will be 0.1 again with a minimum value. Then 300 with 100, that 100, it will be 0.3, because 0.3 is smaller than 0.5 what we have. Then 300 with 200, it will be 0.3 again, and 300 with 300 will be 0.3. Now this matrix what I got is low cross medium. So every value, individual value of low is verified with medium. Similar lines I should get a Cartesian product of low with high. Low 200 and 300. So low with high, it is 0, 200, 0, 300 also 0, because it is the smallest value. Next we have 200 with 0.1 with 0.8, so 0.1 is minimum. Okay, then we have 200 with 200, that is 0.1 is minimum again. Then 200 with 300, it is again 0.1. Then 300 with 100, it is 0.3, and then here it is 0.3, and again it is 0.3. So this is low cross high. On the similar lines, I can have R with respect to medium cross high, R with respect to, yes, this matrix I am going to get again 100, 200 and 300, 100, 200 and 300. So medium cross high, again we have value. As per the formula, it is the membership function with respect to low and membership function with respect to medium. The minimum of these two functions. So 100 with 200, it is 0.1, it is 0.3. Then we have 200, 0.1, then 0.1, and here we have 0.3 with 0.3, 300 with 200, it is 0.3, again it is 0.3. So these are the three matrix what you get after having the Cartesian product with all these three fuzzy sets being given, that is low, medium and high. So this is what we have. These are the different types of problems what we have. Classical relation with fuzzy set. We will continue with the next membership functions in the next class. I request you to go with some solved problems, also with the exercise problems similar to these kind of things whatever I have solved.